Hello everybody, hi, welcome to the webinar. Let me introduce myself first. My name is Monika. I have done my BTech from IIT and I'll be taking you a webinar today. So today we are going to discuss some questions that are asked in previous year Math Olympiad. So let's see what the questions are. So here we have the first question. So which digit should come at the place of the star, that is number unavailable for us, to make the number, this complete number, divisible by 3. So first of all, when you read the question, you can understand that this is based on the divisibility rule of 3, right? If you know the divisibility rule for 3, this is a very easy question. Now just think about it. So divisibility rule for 3 is that if you have, let's say, 274, right? If you have a number 274, so for it to be divisible by 3, if you want to check it, so just add the digits of the number. So you have 3 digits, right? This is a 3-digit number. This is 2 plus 7 plus 4, which will be giving you 13. Now, clearly 13 is not divisible by 3. So therefore, 274 is not divisible by 3. So similarly, here, if you want to check this number, which one digit is absent here. So how to know that digit which is absent here? So let's see that. So here we have 8 plus 7 plus 3 plus the digit which is absent, right? So it is given that we have to find out that star, the missing digit, such that this whole number, this complete number, 4-digit number, will be divisible by 3. So for it, we have to know the sum of the digits, right? Yes, let's find out the sum of the digits with the available digits we have. So that is 8 plus 7, that is 15, plus 3, that is 18, right? So we have 18 from these addition of these 3 digits we have, plus the extra digit which is absent here. So now clearly you see that 18 is already divisible by 3. Even if, see, this star, this missing digit can be 0 also. So that you will get 18 plus 0, which is 18, and which is divisible by 3. Now the next possible number to be should be 3, because then only you will have a number which can be divisible by 3. If you have 2, that will result in 20, right? 18 plus 2 will be 20, and clearly that will not be divisible by 3. So that's why you should have 3 as the missing digit. Otherwise, the next possible thing is you can have 6 too. Then you will have 24 as a sum of all the digits you have, and that clearly is divisible by 3. So if you see the options, so 2 is not possible and 4 is also not possible. Since you can see 18 plus 4 will be 22, and 22 is not divisible by 3. And also 7 is also not possible. You can check 18 plus 7 is 25, and 25 is clearly not divisible by 3. So that's why 3, this is the answer. You can have the missing digit, that is 3. So your number should be 8733. So this is the number that should be there, and it is divisible by 6. So this is how we solve the divisibility rule, right? The question which is based on divisibility rule. And if you recall, we have more divisibility rules, right? I mean, you have the divisibility rule by 2 also. What do you recall by that? Divisibility by 2. I mean, when we say divisibility by 2, how a number should be there? So here, for a number to be divisible by 2, it should be an even number. Any kind, which is 4-digit, 5-digit number, anything, it should be an even number. So to identify quickly, see, any kind of number you have, we will take the same number as we have seen the question, right? Now, to identify whether it is an even number or not, just see the unit place. The number which is there in the unit place, that is 3, is clearly not an even number. So in units place, if a number has in the units place either 0 or 2 or 4 or 6 or 8, if you find these numbers, one of these numbers in the units place, then the entire number will be divisible by 2. That's how you can identify, right, for a number if it is divisible by 2 or not. Now we have already seen divisibility rule for 3. Now coming to divisibility rule for 4. So how to do the divisibility rule for 4 here? So if you want to find out the divisibility rule by 4, the end you have to see the last 2 digits. That is the last 2 digits. That is the digits which are in tens place and ones place, units place, we can say. So you have to see these 2 numbers, like let's say 8 to this one. Just, if you have this number and just see these 2 numbers, that is 5, 6, 56. Just see if 56 is divisible by 4 or not. So by that you can identify whether the complete number 8, 7, 2, 5, 6 is divisible by 4 or not. You can easily identify. So similarly, we have divisibility rule for all of the 5 and 6 and 8 and 11 and 10 also. So whenever you have a question on divisibility rule, just stick to the definition of them and you can easily solve the questions. So let's move on to the next one. Right. Here we have a missing number given in a mathematical statement. So that is 0.1 into 7 is equals to 0.21 into 4 plus 0.21 into a missing number. So we have to find out. Now you see, you can normally multiply this and find out. There is no effort in that, but if you just look at the question closely, this is based on the properties of the numbers. Now you see that you have learned that in, you can see, I'll mention that here. If you have A into B plus C, you know the distributive property over addition, right? And this is just like that. Now if you have A into A, B, C are just any number. They can be decimal, they can be integers, they can be natural numbers, they can be whole numbers, anything. So if you have this situation, now you have to distribute A to both B and C. So we can write it as A into B plus A into C. If you see, we have similar situation over here, right? I mean, we have a missing number here, right? And you see the number, this is 4 and you have 0.21, the same number which is repeating here, 0.21 into some missing number, that is C here. So what should be there here? It should be 0.21 into 4 plus missing number, right or not? This is the way it should be there. But we are given that. We are already given this as 7. So what number should be there here for it to be 7? This complete number is given as 7 for us. So the missing number should be 3, right? Then only you can have, see, then only you can write 0.21 into 4 plus 3, which can be written as 0.21 into 4 plus 0.21 into 3. So this is the distributive property over addition, and based on that we have solved this. So moving on to the next one. Now we have the question that is, what fraction of an hour is 45 minutes? So this is clearly based on fractions, right? If you see the question, you can understand that. But we want to find out what is a fraction of 45 minutes in an hour. Now that means 40. See, if you have an hour, that is one. We know that 1 hour. I'll change the colors just a minute. So if you have 1 hour, right, that is clearly equals to 60 minutes. You know that already. 1 hour equals 60 minutes. You're having a pizza, right? And you make it half. That is right, half hour. And the total of the complete hour, you take half of it. So in the complete hour, you just take the half of it. So that will become 30 minutes, right? Since you're taking half of the hour only. Right. We want 45 minutes, right? I mean, if you just see closely, 45 minutes is actually 30 plus 15. 30 minutes plus 15 minutes. That is you already have half an hour with you, but you want another 15 minutes for you. So let's see what does 15 minutes signify here. See, you have 30 minutes, right? If you take half in that, what it will become? It will be 15 minutes, right? Half of 30 minutes is 15 minutes, right? So that means in half, it's like this. I'll draw the figure. So if you have a complete pi with you, and you made it half, okay, that's fine. And this is the half we have, 30 minutes. Now what are we doing is, we are again making it half, again fold it half. So this part, this red part, is actually the 15 minutes part. So what it will signify? It signifies, you see, if you look at it closely, it will signify 1/4 of the complete hour, half of the half. So this will signify 1/4 of the hour. 15 minutes signify 1/4 of the complete hour. So this is going straight forward. That means actually we have half an hour with us, right? Plus also 15 minutes extra, that is 1/4 of the hour with us. So that if you take LCM here, you will get 4, right? 2 and 4, LCM is 4. So you get 2 plus 1, which is 3/4. So 3/4 is the fraction of the 45 minutes in an hour. So this is going straight forward actually, but you can also do in the reverse way. That is, we know that, let me just erase this part. So we know that 1 hour is 60 minutes, right? And you clearly see that 45 minutes. 45 minutes is not complete hour. It has some minutes missing, right? So that means, 45 minutes is actually, if you write it, it is 60 minutes minus 15 minutes, right? Yes. So that means in a complete, we know that 60 minutes is 1 hour in fraction. That is complete one you have, one apple or one pie you have. Minus, we have just seen that 15 minutes represent 1/4 of the pie you have, a quarter, right? It represents that. So it is 1/4. It is, you have complete pie and you remove the quarter from it, 1/4 from it. That is 1/4 part of it. That will, again, you can take the LCM here, that will become 4, right? And it is 4 minus 1, which is 3/4. So again, you get the same answer, which represents the 3/4 part of an hour is 45 minutes. So that's why this is the answer. D is the answer. So moving on to the next one. Coming to this one, we have a question regarding Roman numerals. So we have which of the following Roman numeral is equals to 119. So we have a number given for us, 119, and we have to represent that in a Roman numeral. And you know that we have certain specifications in Roman numerals, right? Like L represents 50, right? And M represents 1000, right? And D represents 500, right? C represents 100. Right? If you want to represent a number, you will make use of these representations, right, to find the number in Roman numerals. So how to write 119 here? And so let's see. The first thing here we'll do is we'll split the number. So that is, we have 119, right? We can write it as 100 plus 19, right? So we have removed the larger number that is possible from it, that is 100. So we can represent that as C. Okay, then the remaining is 19. Now 19, you can again represent it as 20 minus 1. Now whenever you are representing a number in Roman numerals, if you want to add a number, you will write it to the right hand side of C. Now if you are adding 19, so whatever 19, the representation of 19 is, you will write here in the right hand side of the C, not left hand side. Now, to come into the representation of 19. So 19 is clearly 20 minus 1. Now, you are subtracting a number, right? So 20 is represented by 10 plus 10, right? That is this one. But you see that you can also represent this here. You are subtracting 1 from 20. So we can also do this by writing it as 10 plus 9. Just separate the biggest number that is possible here, that is the tens digit, because that is more clear to write. Because if you write 20 minus 1, you have 20 represented by x and x, and this is 1, which is represented by 1 only. So you cannot write it as 1xx. This is not right. Why? Because you in Roman numerals representation, you always have to write the larger number to the left hand side and the smaller number to the right hand side. Now you see this is 9, it will represent 9, right? And this will represent 10. That is not possible. So that's why what do we do is, so moving on to the next question, we have here, which of the following Roman numeral is equals to 119? So we have the number 119, we have to represent in the Roman numerals, that's right. But we also know that Roman numerals have certain specifications, right? That like M is represented by 1000, right? And L 50 is represented by L, and C is represented by 100, 10 by X, right? To represent 2, you have these 2 marks. So this representation goes, and these are fixed. And we also have the rule that whenever you represent the Roman numeral, you will have to write the largest number to the left hand side, and as you go right, your number should decrease. So that's the rule for the Roman numeral. Now we can go through the options here. So let's go first by writing with the number itself, not by the options. I'll also explain the options later. So here we have 119, right? Okay, let's write 119. So now split the number first. That is 100 plus 19 we have. Yes. So okay, we have 100 that we clearly have by C. Now the next smaller number, that is 19. We have to represent 19. So if you just see 19 is actually 10 plus 9, just split the number you have. Right? 19 is 10 plus 9. Now 10 is represented by X, right? And again 9, here we don't have any direct representation for 9. So we can just write 9 as 10 minus 1, 10 minus 1, which now whenever you're subtracting a number from the 10 and you have to write in a Roman numeral, you have to write to the left of it. So 9 will be represented by this one. So when you write this one left side to X, that means you are subtracting 1 for 9. That will give you 9. So it is something like this. So 19 is represented by this one. So we have written 9 as 10 minus 1, which will be giving you this one, and 19 is X, 1, X. So this is 19. Now you are adding 19 to 100, right? So you will place this entire thing to the right hand side of C. So that is X1, X. So this is the number 119, that is 119, that is asked for us to represent in Roman numerals. So that's why your answer is C. Now you may ask, why not A or B or D? So we'll see that. We'll come to that. We're coming to that. So the first one here. Now you see, we have already studied the specifications and the rules of the Roman numeral. Now I've already mentioned that. Now the largest number to be represented at the left hand side. Now you see this is 10 and this is 100. You cannot represent, you cannot write a smaller variable here, smaller represented X or anything which is smaller than C. You cannot write on the left hand side. Always start with the largest number. So you have to start with C. You cannot start with X. So that's the basic rule for the Roman numerals. So that's why you can say this is not the correct answer. Now coming to the second one, you have yes C, that means 100, and plus XX, that is X means 10, plus 10, plus you have 1X, that means you are subtracting 1 from 10, that is 9. Now you clearly see that it is 129, not 119. So that's why B is also not the correct answer. Now coming to D. So D, it is starting with D. Now D variable represents, yes, it represents 500. It is clearly not 100. Now you want the number 119, not some 500s, right? So that's why this is not the correct answer. So C is the correct answer. So moving on to the next one. So what least number should be added to 23rd multiple of 5 so that it becomes a multiple of 4? Now here, as you read the question, we are in multiples, right? We want to find out some multiple of 5, etc. But if you read the 5 into 5, the 5 is the first multiple of 5, then 10 is the second multiple, and then 15 is the third multiple. Now you see, if you want to find out the 23rd multiple of 5, what is it? It is just 5 into 23. So that is just 115. So 115 is the 23rd multiple of 5. So now the question is about this only, but we have to find out the least number that should be added to this 23rd multiple so that it becomes a multiple of 4. Otherwise, you have to add a number such that 115 after adding the number will be divisible by 4, right? Every multiple. See, if you have a multiple of 4, obviously it will be divisible by 4. That's what we want to do now. So what is the number you want to add here so that the resulting number will be the multiple of 4? You want the multiple of 4. Now let's start with 0. Well, 0 will not do anything. So let's start with 1. So if you add 1 here, it will be 116. Now you clearly see that it is a multiple of 4. How? It is divisible by 4. You see the last 2 digits, as we have discussed already, the last 2 digits, 16. 16 is divisible by 4. So therefore, 116 is divisible by 4. That means it is a multiple of 4. That's how you identify. But you can check by adding 2 also. That will give you 117. Now it's clearly not divisible by 4 because 17 is not divisible, the last 2 digits. So that's why 1 is the correct answer. Similarly, we can do by adding 6. That will be resulting as 21, and the last 2 digits 21. 21 is clearly not divisible by 4. That's why this is not the correct answer. And also let's see by 7, right? And that will result this one. Well, 22 clearly not divisible by 4. So that's why this is also the not correct answer. So this is how we do the questions, right? I mean, just stick to the basics. You already know everything. So it's just a matter of implementation. So I hope all the best for upcoming exams, and bye everybody. I hope you have understood everything.